All right, so we're going to look today at how to solve systems of equations using substitution. And these are all linear systems, meaning that they are equations that will create straight lines. So when we're using substitution, basically we are substituting an expression in for one of the variables. And so our variables are x and y. The way this first one is set up, we have y equals 3x for our first equation and y equals negative x minus 32 for our second equation. And so since both of these are already solved for y, we're going to take 3x because y is equal to 3x, and we are going to plug that in for y right down there in that second equation. So what that gives us is that 3x is equal, so y is 3x, 3x is equal to negative x minus 32. And so now I have only one variable, and with one variable I can actually solve. So I have variables on both sides, and I typically like to get rid of the smallest group of variables. So I'm going to get rid of a negative x by adding x to both sides. That gives me 4x. Over here, I have a zero pair, and that equals negative 32. So then to get rid of times 4, I divide by 4 on both sides. 4 divided by 4 is 1. 1 times x is x. So I have x is equal to negative 8. So I'm almost done, but not quite. So then I take that negative 8, and I'm going to plug it in here to figure out what my y is. So y is equal to 3x. So 3 times negative 8 gives me negative 24. So my solution is negative 8, negative 24. It's a good idea to also go ahead and plug in these variables into that second equation to make sure it works for both. So y is negative 24. And then I have negative x, or the opposite of x. So the opposite of negative 8 would be 8, and then minus 32. And yes, indeed, 8 minus 32 is negative 24. So my solution does work in both of these equations. Now, because I got a point for this solution, this tells me that when I graph these two lines, that they are going to be intersecting. They intersect at this point. All right, so then my next example, I have x equals negative 2y plus 4 and 3.5x plus 7y equals 14. And so here, I don't have y solved for either one of them, but the only requirement for solving with substitution is that there's one variable isolated in one of the equations. So I have that requirement met right here. I know that x is equal to negative 2y plus 4, so x is already isolated. I'm going to take this entire expression and plug it in right there where that x is. So that turns into 3.5 times x, and now x is negative 2y plus 4, and then plus my 7y equals 14. So that's a y. So I only have y. I'm solving for y now. So I'm going to distribute 3.5 times negative 2y is negative 7y, and 3.5 times positive 4 is positive 14y, or 14, no y. And I have plus 7y equals 14. So now I'm going to combine like terms, and I have negative 7y and positive 7y actually cancel out. I have no y's left. I'm left with 14 on the left, and I have 14 on the right. So in this case, I have 14 equals 14, which is a true statement. 14 does indeed equal 14. And so because this is a true statement, this tells me that any combination of numbers that I plug in will work in both of these, which means that there are infinite number of solutions. I won't say any, but it means that these are actually the exact same line. If if I was to solve and graph these, they would be the same line. So if you get a true statement, you have infinitely many solutions because these two equations represent the same line on a graph. All right, last example here. I have 6x plus 2y equals 10 and negative 3x minus y equals negative 8. So you'll notice here that I don't have a variable solved. I have my constants isolated, but I don't have a variable isolated. So I am going to choose which variable I want to isolate. In the first one, I have coefficients with x and y. So I notice right away that this y is almost by itself. And so I'm going to isolate this y. It's got a negative 1 in front of it, but I'm going to go ahead and add y to move it over here. So that makes it a 0 here. And then I'm going to add 8 to get rid of the negative 8 over here. So I have negative 3x plus 8 equals y. So now y is isolated. I'm going to take this expression and plug it in right there. So let's do that. I have 6x plus 2 times y, and this is what y is equal to. Negative 3x plus 8 equals 10. Then I'm going to distribute. So 2 times negative 3x is negative 6x. 2 times 8 is 16, and that equals 10. So now I'm going to combine like terms, and again, I notice a positive 6x and a negative 6x cancel out. They make a 0. And so I have no x's left, and I have 16 is equal to 10, and that is not true. This is a false statement. So that means there is no solution. Now, in a system of linear equations, no solution indicates that these are parallel lines. So they will never, ever cross. And so that is why there's no solution. So if you get a false statement at the end, there is no solution because those are parallel lines.